Today, we're gonna start learning calculus. Things get real. Make sure you watch this video until the end to learn how to derivate. Our goal is to create a framework that helps us derivate and integrate functions. If we have to derivate a simple function, things will be much easier. And if we understand a function well, even if the function is too complicated, our work will become easier as well. This is why we want to understand functions very well. The way we do this is by looking at functions that are easy to understand, and we use these easier functions as building blocks. The easiest functions are polynomials. These are easier to understand. That's why we study them in school. We learn equations for lines and the quadratic equation very early in our education. Next are radical functions, square root, cubic root, fourth roots, etc. Trigonometric functions require more practice to understand, but when you do enough exercises, you realize they are not as complicated. Our final building block are logarithms and exponentials. These are the functions that causes more problems to students. You want to understand all of these functions and practice doing exercises with all of them. Using these functions, we can model almost any natural phenomena, especially when we combine them. Yes, we can glue simple functions to obtain more complex functions that are still intuitive. We can sum two functions. If you understand f and you understand g, you can understand f plus g. The same thing happens for f minus g. The product of two functions is another way to glue functions. And for g not zero, we can do f divided by g. Finally, we can do g inside of f. For example, we can do the polynomial 1 plus x squared inside the square root, or sine x inside the exponential. Notice how these techniques allows us to obtain more and more complicated functions. For example, we can start with the polynomial 1 plus x squared and put it inside the square root, and the trigonometric function sine x and put it inside the exponential. And then consider the sum of these two functions, and then the quotient of this sum by the logarithm of x. And there is no limit to how complicated we can go. The important thing is that we use our building blocks and we glue them following the previous rules. We can use a new framework to learn derivatives. First, we have to learn how to derivate the basic functions, our building blocks. We maybe can do another video about this. Then we have to learn to derivate functions that are glued from other functions following our rules. For this, we use rules of differentiation. The derivative of a sum is the sum of the derivative. Sums are easy to derivate. The rule to derivate a product is so important that it has its own name. It's called Leibniz rule. The derivative of the product, fg, is derivative of f times g plus f times derivative of g. The quotient rule, the derivative of f divided by g, is derivative of f times g minus f times derivative of g, all divided by g squared. Finally, to derivate a composition, we had the chain rule. The derivative of f composed with g is f prime g times g prime. This is a summary of months of calculus, and with this framework, you can start learning to derivate. In 1687, Isaac Newton published Philosophiae Naturalis Principia Mathematica. In this work, he reduced the study of mechanics to solving one differential equation, an equation with derivatives. 333 years later, modern physics still follows his example. Relativity is solving Einstein's field equations, which are nothing more than differential equations. Quantum mechanics is solving Schrödinger equation, also a differential equation. When you learn derivatives, you are taking the first steps to understanding all of modern science. But the first step is to learn to derivate.